Thank you very much. My name is Onishi. I'm from Midwest Carolina. It's my big pleasure to come here to share our challenge to audiences, the Korean industries. Let me briefly explain our company. We are the one of the biggest shipping company in the world. Our fleet size is we have 935 vessels, and including 107 LNG carrier. The LNG carrier fleet is one the biggest at this moment. Our fleet portfolio is quite well balanced. The 1/3 is the bulk carrier, and other 1/3 is energy sector, and other 1/3 is the other transportation sectors. So this is our company's brief explanation. Our target is zero emission achieved 2050. Almost other companies the same. The 7% reduction of the GHG will be by fuel transition. The other 20% is by technology, like a DX or fuel saving device, something like that. 20% of the energy saving is huge. How should we do? The wind in the Korean language is bung. Is it correct pronunciation? Yep. The wind is the best candidate to assist the ship propulsion with no emissions. There's the possibility to reduce fuel consumption dramatically. So dramatically meaning is the underwater devices is already full of capacity. It's very busy under the water. But above water, it still have a lot of room to improve the ship's efficiency. The wind is the best candidate. We have very long history to get familiar with the wind. Actually, we start the R&D of the Wind Challenger in 2009. We built the test facility in 2013. Then first actual system on the vessel is 2022. That's 3 years ago. Then last year, second one was delivered. The next year, together with Hanwha Ocean, we will deliver 2 energy carrier with wind propulsion system. Then we are going more forward. The wind propulsion assist system is a now trend of the shipping industry. But not only the trend, it will be a mainstream of the energy saving device, because the underwater device is most of underwater device is put only one. But wind propulsion devices, we can put more if we have the space. The Wind Challenger is one of the leading group of the wind propulsion system. But other system also will come up to the commercialized area. So now we have a lot of choices of the wind propulsion system. The unique point of the Wind Challenger is the leading of the R&D is by shipping company. The shipping company, the point of view, the high efficiency, this is common. And high level of safety, this is also very important. So Wind Challenger is quite unique, the wing shape. The red area is the headwind. We cannot generate anything, but about 310 degrees of the wind direction, we can generate the thrust. The thrust generating mechanism is a little bit different. The blue area, the side wind, we used the max lift, the lift using to the thrust. The follow wind case, we use a drag of the sail. So this kind of mechanism, by using this kind of thrust generation mechanism, we acquire the very wide effective area, effective direction of the wind. So this is most important, the stability. So the wind challenger is, you can see the retractable system. The left-hand side, the picture shows the actual sea condition. This is not special, it's quite normal. We are always facing this kind of sea condition. The wind challenger is the only device can control the center of gravity positively. So this is the most important function to get safety navigation. Let's see more deeply. So this is the sea state, the picture. The left-hand side is calm to stormy condition. The calm condition and also heavy weather, the sail is full height. The center of gravity is almost center of the sail. The sea condition getting heavier, getting rough, we put one step down to, according to that, the shear center of gravity also down. The worst condition, the sail leave completely, then center of gravity also down to contribute the stability. So ship's stability is depending on the devices on deck. So this is the reason of the most safety devices of the wind propulsion system. The other unique point also, let me check, this is the right-hand side shows the characteristic of the wind, our sail. We have the max lift point, and also we have zero lift point. So zero lift point is kind of the neutral position. So our control system also have the new zero lift mode, means so zero lift angle, so automatically follow the wind. That function we can use for the drifting and anchoring and berthing to minimize the sail effect. This is also very important function during the berthing or other situation which we don't want to affect by the wind. The mechanism is quite simple. We have telescopic mechanism and throwing mechanism. The telescopic mechanism is achieved by the rack and pinion system. It's quite simple, but very robust. And the throwing mechanism also gear and electric motor. It's quite simple and very familiar technology. It's not new. The first stage motor is push up the sail, and the second stage motor, the push up the first and second sail together. So this is the mechanism. So second stage motor is a little bit bigger than first stage. Actually, the two motor is enough for lifting up, but we put 4 for redundancy. The throwing mechanism is also the same. The 4 electric motor with pinion engaged with the big throwing gear. So this also, most of the case, 2 motors power is enough, but we put 4 to redundancy. So in any case, we can use the sail. Our development is not only sail. We development also control system and weather routing system together. This 3 function is very important for effective and safety operation. So later I can explain I will explain the weather routing system. And the right-hand side, this also quite unique activity with the third party at the load register. The fuel saving calculation, the method itself is verified by the load register. We put into the software this way. So all the data, onboard data is calculated, inputted to the calculation system, then fuel saving amount is output automatically. The calculation method is verified by load register. In the future, maybe the saving amount can be trading, something like that. So the third-party verification of the fuel saving amount is quite important. So we already doing with the load register. The weather routing system is very powerful. Our original weather routing system is the motion model of the ship is already integrated in the system. Normally, from Japan to North America, we use the Great Circle route, like that, red line. But weather routing system suggested more effective route, depending on the characteristic of the wind propulsion system. So this is the wind challenger. So to avoid headwind and to get the side wind or follow wind. So this routing, the method is not our past experience. So this route suggestion by using the weather is most important for effective operation to the captain or a ship's crew. As I explained before, we already work with Hanwha Ocean to two-cell propulsion system that will be delivered next year to ship. And our activity is get more forward with other shipyard. We are collaborating with all three Korean major shipyards, the Hyundai Heavy Industry and Samsung Heavy Industry, and also Hanwha Ocean is most closer delivered ships next year. So this is the new generation of the energy carrier to use more deeply of the wind power. This is for accommodation to multiple sail to clear the visibility problem. So two sail in the conventional energy carrier, in case of the wind challenger, two sail is the maximum to satisfy the SOLAS visibility regulation. But forward bridge is clear of the visibility problem. The bow bridge and bow accommodation and space, the resulting of that, the space we have in the aft. So the cargo machinery room is put in there, the very fresh and very wide area of the for the wind propulsion system on deck. And with Samsung Heavy Industry, so this is also the same concept, but a little bit different. The only bridge put on the forward, and aft almost same as the conventional. So this is also good. And how can I say, development activity term is very short because of the most of the area is same as the convention. So this is also a good concept. So bow bridge and still aft accommodation and optimize the sail on the deck. So this is also very good concept. This slide is most important. Full sail on the energy carrier can save the 15 to 20% a year average. So peak saving is more than 30%. This is our own simulation. Our own simulation is, we already have the experience. So our first one, Shofu Maru, they already 3 years operation. So this is the 24 hours average monitoring result. The average saving is 70%, and peak saving is over 30%. So this is a little bit good, nice day for wind propulsion system. The nice wind direction and stable wind direction. So this is a little bit better situation, but it achieved the 70% average day saving, and peak saving is more than 30%. So this kind of actual performance, we feed back to our simulation system. So for the next step, we need to increase the production capacity to more using the wind power. The sail, now most of the sail they fabricated in Oshima shipyard in Japan. Sail can transport physically, but not easy. So we found the Korean power fabrication partner, production partner, the Sambo industry. So we have two production base in Japan and Korea. So we are planning to scale up the production in order to meet increasing demand with the powerful partners, Oshima Shipyard and Sambo Industries, SB Sambo. So we're moving forward with the innovation ideas. So may the wind force be with you. Thank you very much.